Okay, here is my plan for an alternative water wheel with only 8 spokes. Label the exact values of the x and y coordinates for each point on the following schematic drawing of the water wheel. Hint, you may want to begin this work by finding the length of the brace shown in the diagram. Okay, 8 spokes, giving us a hint to find this. Of course, we're going to need to use trigonometry to do that. We know that these spokes make a 90, but instead of 12 of them, now we have 8. If we have 8, what does that make? This, it makes it 45, because 360 divided by 8 is 45. So all those 45s around the circle would add up to 360. So if that's 45 and this is 90, I know that this is 45. We know that the spokes are 1. Okay, that gets us something, but we don't quite have the pink line yet, right? Well, this is an isosceles triangle because both of those are 45. So what do I know? I know that those two pink segments are congruent, because if their base angles are equal, then those two sides are equal. So if they're the same thing and it's a right triangle, I'm trying to find that x value. So I'm going to use there's a lot of different ways to do this. You could use the Pythagorean theorem, which would just be x squared plus x squared is 1, which would be 2x squared is equal to 1. And then you could just solve it like that all the way down. Or you could just do like the sine of 45 is equal to the opposite x over the hypotenuse. And then you could just, all you would have to do is just do the sine of 45. So why don't you go ahead and either one of those two ways try to get that, okay? So when we do that, we get the decimal, which is equal to 0.707, which is it's not really something that we want, right? Like when I do this, I get this and blah, 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 blah. So remember, we want to be exact. Okay, so the reason why we use simplified radicals is because this is very exact. Okay, if I start rounding everywhere and I do all these different circle calculations, I'd eventually, my numbers would be off just a little bit, which eventually would kind of grow to a lot. So let's work through this way to here, okay? Now, a lot of you already know maybe the answer to this, but I just want to kind of show you the why. So we would take the square root of both sides, and we would get x is equal to the square root of a half, and then the square root of 1 is just 1, remember? And then the square root of 2 is that. And then we can't have a radical on the denominator, so we multiply it out, remember? And that tells me that x is equal to the square root of 2 over 2. That is this in a more exact form. So now I know that this is the square root of 2 over 2. And this is the square root of 2 over 2. Okay, now I've gotten somewhere, and I just have to do what we did in the last one. So now that we have the length of that pink line that we needed there, we actually got a lot of things. We're able to now kind of start tackling the problem, knowing that, this is 45 degrees. And then we got to think about it in radians. Ooh, okay. Well, we know that this is pi over 2. We know that this is pi. Okay, so this angle right here must be half of pi over 2, right? So what's half of pi over 2? Well, that would be pi over 4. So this is pi over 4. And then you just go around the circle and find so each one of those is pi over 4. So if I wanted this one, I would have to go this pi over 2 plus pi over 4. So pi over 2 plus pi over 4. And if you know how to do this, you can fast forward it to when I have all the numbers on there. But or you could just also try it on your own. But this would work like this, where this would become 3 pi over 4. So this is 3 pi over 4. And then you could eventually just work your way around just work your way around the entire wheel, okay? So, maybe I'll do that for you. So remember there's a few different ways to do this, okay? So again, if you've got it, go ahead and fast forward. But this angle here, what is it? It is 225. And if I want it in radians, I would go 225 times pi over 180. And then that would give me 225 pi over 180. And then I would divide both of those up probably by 15, I'm guessing. And well, that's not the greatest common denominator, but it's a common denominator. But that would give me 15 pi over 12, which is 5 pi over 4. So this is 5 pi over 4. I don't really like that way of doing it. Obviously, it just was too much reducing. So I might have just thought of it as, okay, 180 is pi, and I just need to add one more 45-degree angle. So I could just have done this, and that would get me 5 pi over 4. Okay, so now that we have 5 pi over 4, we know that 270, an easy way to think about it, is just 180 plus 90, which we already did in the last video. That part's going to be the same. What was it? It was 3 pi over 2. It was 3 pi over 2. And then the next one is just going to be 3 pi over 2. Add 45 degrees. And give us a common denominator here, which is going to give us 6 pi, which is going to give us 6 pi over 4, which is going to give us 3 over 2 pi, which isn't good. Wait. Oh, 7 pi, excuse me. 7 pi over 4, because 6 pi plus 1 pi. Okay, 7 pi over 4. And then our last one, of course, is just 2 pi. You would get 8 pi over 4. All right, so sine of pi over 4. Now the time to do the actual work. Okay, here's pi over 4. Sine is the y value, okay? So let me erase all of this stuff over here. It's the y value. Okay, so what was this coordinate again? It was the square root of 2 over 2, comma the square root of 2 over 2. What's the y value? It is the square root of 2 over 2. Okay, and then we got 5 over 4. So that's this angle here. And just think about it. All the distances are the square root of 2 over 2 for the triangles at least. But this part here, my y value would be the negative square root of 2 over 2. So I get the negative square root of 2 over 2. You might pause it and try to fill in the rest of them. 3/4 pi. Okay, 3/4 pi is right here. And my y value would be what? I'd have to go left the square root of 2. Oh, I'd have to go left and up, right? So my y value would be this positive distance right here, which is the square root of 2 over... Oh, but that's cosine. Sorry. Let's just go on to... We'll do cosine last, but you know that it's the x value, right? So you probably could have figured it out there. Cosine pi over 4. Okay, here's pi over 4. Cosine is the x value, so the x value is the square root of 2 over 2. Cosine negative pi over 4. I like this question. So remember, negative moves us in a clockwise direction. So that means it's coming down here, pi over 4, which means it's this angle, which means it's this triangle. And we are doing cosine, which is the x value. So what is the x value of this? Well, this would be the positive square root of 2 over 2 over, and the negative square root of 2 down, like that. So this one is square root of 2 over 2. And then I think you can get the rest of them, so I'm not going to talk you through each and every one. Maybe we'll talk about 3 pi over 2. So this one, remember the sine of that point, and what is that point? It's this. And the sine is the y value, so that's -1. And then 3 over 2 pi, well, that cosine of that is the x value, which is 0. And then they give us another curveball here at the end, 11 pi over 4. Remember, make that a mixed number. Okay, what would that be? That would be 2 and 3/4 pi. Remember, the 2 takes us 2 pi all the way around the circle. There's the 2, and then I have to go 3/4, which is here, and this is a sine problem. So I'm talking about this coordinate, and that is negative square root of 2 over 2 to the left, and the square root of 2 over 2 up. Okay, so what is my y coordinate there? It's the square root of 2 over 2, positive. Okay, moving on. Okay, during the spring runoff of melting snow, the stream of water powering the water wheel causes it to make one complex revolution clockwise every 3 seconds. Okay, write an equation to represent the height of a particular paddle of water wheel above or below the water level at any time t after the paddle emerges from the water. Write your equation so the height of the paddle will be graphed correctly on a calculator in degree mode. Okay, so every 3 seconds is the key to this problem. Okay, so every 3 seconds I would have my circle, and so this one's divided into thirds. Okay, so however that would be, it would look something like this. Or would it? Into thirds. Yeah, that's kind of into thirds there. Okay, so it'd be like 1 second, there's second 1, there's second 2, and there's second 3. Okay, so how long for 1 second? Well, it would move 120 degrees in 1 second. So, what we're talking about here is we're talking about the y value at those points. Okay, so this one would be in degrees. It would be h, we'll just say h of t is equal to the sine of 120 t. Okay, and it's sine because we're talking about the y value. Okay, all right, and then on the next one it says do it in radians. Well, this one in radians, h of t would equal the sine of what? So we're not dealing with 120 degrees now. We're dealing with radians. So I would go 120 times pi over 180, which gets me 120 pi over 180. And if I reduce that, I get 2/3 pi. So instead of writing 120 on this one, I write 2/3 pi t. Revise your equation so the height of the paddle will be, that was supposed to be written down here, sorry. Okay, during the summer months, the stream of the water powering this wheel becomes a lazy river, causing the wheel to make one complex revolution every 12 seconds. Write an equation to represent the height of the paddle of the water above or below the water level at any time t after the paddle emerges from the water. Write your equation so the height of the paddle will be graphed correctly on a calculator set in degree mode. So this one, h of t, is going to be equal to, well, how long for 1 second on this one? Well, you'd have to do 360 divided by 12, which would get you 30. So this one is 30 t. Okay, so that's how far it travels in 1 second. That's the key there, is finding the unit rate. And then what was 30 degrees, if you remember, in radians? Well, 30 degrees in radians would be, if you haven't memorized it already, pi over 6. So this would be pi over 6t, pi over 6. Oh, a sine of that. So it would be sine of and h of t and h of t. Okay, there we go, and that is it. That is the end of the 6